Have you ever stared up at the night sky and wondered how it will all end? Not just our planet, not just our sun, but everything. The entire universe. It's a question that has captivated humanity for centuries, a cosmic mystery that physicists and astronomers are still trying to unravel. Today, we're diving deep into one of the most mind-bending theories about the ultimate fate of the cosmos, the death of black holes and the end of time itself. Let's start with what we know. The universe is expanding, and is doing so at an accelerating rate. This leads to a scenario known as the heat death of the universe. Imagine a future so distant it's almost unimaginable. Trillions upon trillions of years from now, star formation will cease. The last stars will flicker out, one by one, plunging the cosmos into an eternal, cold darkness. Galaxies will have drifted so far apart that the sky will be an empty black void. The only things left will be the stellar remnants, white dwarfs, neutron stars, and the undisputed kings of the late universe, black holes. These cosmic behemoths are the final punctuation marks of the age of stars. They are regions of spacetime where gravity is so intense that nothing, not even light, can escape. They gobble up any matter that gets too close, growing larger and more massive over time. For a long, long while, it was thought that black holes were eternal prisons. Once something fell in, it was gone forever. But then, in 1974, the legendary physicist Stephen Hawking came along and turned everything we thought we knew on its head. Hawking proposed something extraordinary. He theorized that black holes are not completely black. Due to bizarre quantum effects happening right at the edge of the event horizon, the point of no return black holes should slowly, incredibly slowly, emit a faint glow of particles. This phenomenon is now famously known as Hawking radiation. Think of it like a slow leak. A black hole isn't just a cosmic drain. It's a leaky faucet, dripping away its own mass and energy back into the universe over unfathomable timescales. So what does this mean? It means black holes aren't forever. They evaporate. Now, for a supermassive black hole like the one at the center of our Milky Way galaxy, this process is mind-bogglingly slow. We're talking about a timescale that makes the current age of the universe look like the blink of an eye. The time it would take for a solar mass black hole to evaporate is around 10 to the power of 67 years. That's a 1 followed by 67 zeros. For the largest supermassive black holes, it could take up to 10 to the power of 100 years. A number so large is called a googol. For most of its life, a black hole's evaporation is a quiet, gentle process. A slow, steady whisper of particles radiating out into the cold, empty universe. The larger the black hole, the colder it is, and the slower it radiates. But as the black hole shrinks, something dramatic happens. Its temperature increases, and the rate of evaporation accelerates. It gets smaller, hotter, and radiates faster and faster. This leads to a spectacular grand finale. In the final moments of its life, a dying black hole would undergo a runaway process. As it shrinks to the size of a mountain, then a car, then a marble, its temperature would soar to billions of degrees. In its very last second, it would unleash a final, tremendous burst of energy. This isn't an explosion in the traditional sense like a supernova. There's no matter being thrown outward. Instead, it's a pure, violent conversion of mass into energy, a final, brilliant flash of gamma rays and other high-energy particles. Imagine it. After an eternity of darkness, the empty universe is suddenly illuminated by these final fireworks. One by one, the last black holes, the final holdouts of structure and mass, will detonate in a silent, brilliant blaze of glory, leaving nothing behind but a bath of low-energy photons and other fundamental particles adrift in an ever-expanding empty void. This is the era of the final black hole explosions. What happens after the last black hole has evaporated? This is where we venture into the realm of pure speculation, the dark era of the universe. What's left is a cold, thin, and featureless soup of particles. According to the heat death theory, this is the end. Time itself may lose its meaning in a universe where nothing really happens anymore. The arrow of time, which we experience as the progression from order to disorder, becomes irrelevant when the universe has reached a state of maximum disorder or entropy. Is a static, dead cosmos? Is this bleak picture the only possibility? Not necessarily. Some theories propose even more exotic scenarios. One is the idea of a big rip, where the accelerating expansion becomes so powerful it tears everything apart, from galaxies and stars down to atoms themselves. Another is the big crunch, where gravity eventually wins, reversing the expansion and causing the universe to collapse back in on itself, potentially leading to a new Big Bang in a cyclical process. However, the scenario of black hole evaporation offers a unique and poetic end. It suggests that even the most permanent and destructive objects in the universe are ultimately temporary. They are the universe's ultimate recycling plants, slowly returning all the matter and information they consume back into the cosmos. The final explosions of black holes will be the last interesting events in the history of time. They are the universe's final, defiant roar against the encroaching silence and darkness. For an immeasurable time the universe would have been cold and quiet, but for these brief, final moments, it will be lit up by the ghosts of dead stars. It's a powerful thought, isn't it? That even after everything we know has faded away, the stars, the galaxies, the planets, the universe has one last, spectacular act in store. It is a testament to the fact that the laws of physics operate on scales we can barely comprehend, playing out a cosmic drama that will continue long after we're gone. The end of time may not be a sudden stop, but a slow fade into darkness, punctuated by the final brilliant flashes of dying black holes. Thank you so much for joining me on this journey to the end of the universe. It's a topic that's as humbling as it is fascinating. If you enjoyed this cosmic exploration, please hit that like button. And be sure to subscribe and ring the bell so you don't miss our next deep dive into the mysteries of space and time. Let me know in the comments what you think the end of the universe will look like. Until next time, keep looking up.